Welcome to the second Solarpunk Cities video, which considers swarm intelligence. So what is swarm intelligence, and how does it connect to Solarpunk? Swarm intelligence is displayed by the collective behaviour of decentralized, self-organized systems, which are composed of simple agents that interact locally with each other and within the environment. Examples in nature are ants, bees, even people, and in information technology, network nodes. Swarm intelligence in a beehive allows thousands of bees to collectively solve complex problems that no single bee can realize alone. Through simple, local interactions, bees can achieve efficient decision-making without central control. A school of fish provides another example of swarm intelligence. By sensing and copying the movements of their neighbours, the fish act as one coordinated body without a leader. When a predator approaches, the school contracts into a tight, shifting mass that looks like a single large organism. This confuses the predator, disrupting its hunting pattern. A flock of starlings will display a similar behaviour when attacked by a bird of prey. In Star Trek, The Next Generation, the Borg demonstrates swarm intelligence taken to the extreme. Each drone is linked through the collective. This allows the Borg to adapt instantly to threats, repairing damage and adjusting tactics without central delay. So how does swarm intelligence work? What are its characteristics? The characteristics of swarm intelligence are decentralization, self-organization, robustness, and scalability. Let's now see how swarm intelligence is used in solving present-day problems. In distributed computing systems, networks apply swarm intelligence methods based on the firefly algorithm. Just as fireflies are drawn to the brightest flashes of light, each node in a distributed computer network is attracted to a better effective task routine. Over time, this self-organizing behavior balances the workload across nodes. Swarm intelligence in a distributed computer system can improve resource use by 10 to 20%, making the system faster and more efficient without needing a central controller. Logistics services depend on the planning of routes effectively so that goods can move quickly and cheaply. Let's examine one of the best examples of the benefit from applying swarm intelligence: the travelling salesman problem. The goal is to find the shortest possible route for the salesman to visit a set of cities on a round trip. Here is how the algorithm works, which is inspired by ant behaviour. Every possible path between two cities is given a score. This score reflects two things. First, experience, how often the path has been chosen successfully before. This is just as ants reinforce a good trail by leaving pheromones. Second, efficiency, how short the path is. Once all the algorithmic ants have completed their journeys, the scores are updated. Strong routes are reinforced, while weak or rarely used routes gradually lose their strength and fade away. Over time, this simple rule helps the algorithm discover efficient routes, just like ants finding the shortest trail to food. In robotics, swarm intelligence is applied to coordinate entire fleets of autonomous systems. Imagine drones fanning out over a disaster zone to map the damage. Warehouse robots seamlessly manage shifting inventories, and underwater vehicles working together to explore vast stretches of ocean terrain. In AI and data science, swarm intelligence principles help tame the complexity of massive datasets, highlight hidden patterns, and select the most important features for analysis. Instead of relying on a single, rigid method, swarms of simple agents explore many possibilities in parallel, exchanging feedback to guide one another towards promising solutions. This collective approach not only speeds up processing, but also improves accuracy and adaptability, enhancing the learning capabilities of intelligent systems. Today, the line between swarm intelligence and broader multi-agent AI is fading. Multi-agent AI simply means many intelligent systems working together, like fleets of drones that coordinate flight paths, or virtual assistants that share data to solve tasks more efficiently. In robotics, in smart infrastructure, in defence systems, in smart mobility. And with billions of IoT devices now becoming more connected, swarm-style collaboration is being built into modern AI. What began as swarm intelligence, a trendy phrase in the late 1990s and early 2000s, is now evolving into hybrid systems that mix swarm principles with advanced learning and decision-making. Swarm intelligence is a multidisciplinary field and still offers valuable insights, especially in robotics, sociology, and ecology. Today, swarm intelligence often works under the umbrella of AI research and applications. Like Solarpunk, swarm intelligence is grounded in cooperation, adaptability, and system thinking. This video has presented swarm intelligence in the Solarpunk vision, its characteristics, giving examples in nature, in computing technology, and even in movies. You can find more on the Solarpunk Cities website and can subscribe to the Solarpunk Cities newsletter to get updates on the Solarpunk vision. So join the Solarpunk movement and let's make the world better. Thanks for watching and join us on solarpunkcities.com.